Hello and welcome to today's webinar, which is on 10 things that will kill your IoT application and how to fix them quickly. My name is Jeremy Cowan. I'm editorial director and founder of IoT Now, speaking to you from here in the UK, and it's a real pleasure for me to be your moderator today. Thank you all for joining us wherever you are around the world. We've got a really vital discussion today for anyone who's ever faced a problem with their own IoT application. And we are delighted to bring this to you thanks to our partners at Aeris. So the first thing to do is welcome our speaker in Santa Clara, California. He is Stephen Glapper, and Stephen is Vice President of Product Management at Aeris. Good to have you here, Stephen.
Thank you, Jeremy. Happy to be here.
If you have any hands-on experience in IoT, I guess you'll already know that things can and do go wrong with connected applications. If your business is built on a connected product or service and your remote devices aren't transmitting data as you intended, then every minute that a problem goes unfixed, it costs you money and it costs you customer satisfaction. And Stephen is going to help us to fix this today. But first, there's a couple of things I need to say. Let me tell you first that this webinar is being recorded, and as always, from tomorrow, you can stream this webinar from our website, which is at iot-now.com. We always want to know what you think, and so with no exceptions, this webinar will also be bringing you 2 live polls, and they're coming up. They are totally anonymous, so you can say exactly what you think, and during the webinar, you can send us more questions too. Send them to me at any time, starting right now, and I'll put as many as I can to Stephen at the end. All you have to do is click on the questions icon, type yours into the window, and any that we don't cover today, we will do our best to answer offline. Finally, if you're having any technical issues with the audio or video or slides, you can also use the questions button to get advice from our tech support team. We'll have our opening poll in a minute, but first I want to hand over to Stephen. So, Stephen, the floor is yours.
Thank you very much, Jeremy. And thanks to all of you who've joined us today. We hope to make this an informative and helpful hour for you by sharing some key lessons we've learned from our couple of decades of experience in IoT. I should note, to save you some typing or screenshotting, if that's your thing, that we'll make these slides and their speakers notes available after the webinar. And we'll send that around with the link to the recording. So to get started, I thought it would be useful to expand a little bit on what we mean by experience, by giving you a more concrete sense of the fact base that we're working with here. For starters, our 2 decades of connecting millions of devices all over the world have given us a massive sample size of operational exposure, both as a connectivity provider and as a full IoT stack provider in million-unit scale connected vehicle programs. This massive sample has allowed our team, in preparation for this conversation, to plow through thousands of call center tickets and hundreds of ops team escalation reports to build a detailed and quantified profile of what goes wrong in real-world IoT networks and how those issues can be best detected, resolved, and prevented. Beyond massive scale, particularly in connected vehicles, our sample also includes intense operation across the full range of both fixed and mobile IoT applications that use cellular connectivity, from remote healthcare to fleet management, asset tracking, personal emergency response, utilities monitoring, energy production, and a bunch more. But enough about us. Let's take a moment for our first poll question so we can learn a little about you all. So back to you, Jeremy.
Thank you, Stephen. The first question is this: where are you on your IoT journey? Are you just learning about the industry? Are you in the early stages of a new connected product or service program? Are you recently launching a new connected thing? Or do you have experience with connected things at large scale? So the answers are starting to come in. I'll just run through that quickly again. Where are you on your IoT journey? Learning about the industry, or number 2, in the early stages of a new service or a program. Thirdly, have you recently launched a new connected thing? Or lastly, have you experience with connected things at large scale? And whilst those answers are still continuing to come in, there's a fairly even spread between learning about the industry or being in the early stages, with a slight lead taken by those who already have experience and at large scale. I don't know about you, Stephen. I wasn't quite expecting to see that nosing into the front, but it's good to see, I think, that it is. Was that your expectation?
I was expecting kind of an even balance, which is about what we've got. It's nice that, you know, the IoT industry is not mature exactly, because there's still lots and lots of exciting stuff going on. But it's been around a while. So, and we have customers that have been with us for the better part of those 20 years. So, and one of the comments that I've heard in response to this material, which we've shared with others, is that even if you are, you know, part of an experienced team, there's always stuff you can learn from other people's experience. So that's what we hope to share more of today.
That is very true.
I think we can move on from there as the answers trickle in. So I want to get into. Hang on, just one second here. I got to get back to my. My platform. There we go. I want to get into the way in which we've organized the material here, and talk about really the 3 key lessons that we've learned over our own IoT journey over the past 20 years. Number 1, there's a wide variety of things that can go wrong at potentially very large scale, putting performance, cost, and control at risk for your connected things, and in the worst case, for your whole business. And this is actually a fact. It's happened to people. Number 2, as the well-known saying goes, an ounce of prevention is better than a pound of cure. But when prevention fails, you need rapid detection, root cause isolation, and resolution. And number 3, and this may sound a little odd, but to make that resolution possible, you need to find a way to get some brains back into the situation, which is a concept I'll explain in a bit. To illustrate the scale part of number 1, I want to show you a real-world example in the form of an issue one of our larger customers ran into last fall. What you're looking at here is a 2-week snapshot of the total data sessions per hour for their 500,000 devices. And it shows the common business application pattern of peaks during each weekday and smaller volumes on the weekends. At first glance, week 2 on the left looks a lot like week 2 on the right looks a lot like week 1 on the left. But if you look closer at Tuesday in week 2, what you'll find is that the metric of total data usage by their devices started rising rapidly around 10:30 in the morning for no apparent reason to a large multiple of their typical rates. Something had gone very wrong with this customer's usage per session, as you can see here. Given their large device count, this drove literally multiple millions of dollars in connectivity cost overages over the next few days, and understandably no small amount of panic on the part of their team, while root cause investigation continued to figure out what was causing all this, right? So to emphasize the point, potentially large-scale issues with possibly terminal impact on your business are a real thing in IoT applications. To enable illustration of the wide variety of issues part of our lesson number 1, first we need to talk about cellular for a minute. We tend to assume, as users and app developers, that cellular just works, and so do our apps. This is nearly always true, fortunately, for smartphones and end-user apps, because and the real reason there is because their behavior is under very tight control by mobile operators and the App Store providers in a lot of activity around testing and certification that happens behind the scenes. As a result, understanding how things really work under the hood of cellular and apps at the edge or in a cloud isn't really necessary for us. However, figuring out how to fix an IoT solution when it's broken is a whole other matter. It really does require a deep understanding of how things work across the full end-to-end of the IoT solution. Especially for cellular IoT, you really do have to get your head around a fairly complex technology chain from the thing on one end through the mobile networks and up into your cloud and its support for end user applications. Fortunately, for our purposes today, we don't really need to wade through all this 3GPP detail. We can use instead a simplified view with some unpacking in just a couple of specific spots. The details generally boil down to 4 segments: your connected things, the radio access networks or bands with which they communicate, the mobile core that controls that communication, and your application cloud. The first spot where IoT-specific detail is required is at the edge, where, as we'll see in a minute, the majority of problems get their start. In contrast to the tightly controlled smartphone scene that I talked about, IoT devices and applications typically involve a lot more moving parts, including potentially 7 or more layers of software from different sources, from the SIMS firmware up through the radio module, the device, and local user interfaces. All of those are being revised on their own independent cycles, plus multiple active physical devices like sensors and cameras, and multiple local networks connecting all this. This is a good application of a favorite dry British phrase: what could possibly go wrong? And the answer is lots. I know we advertised 10, so my apologies for overshooting that. But as we dug into our own experience sample, plus some noteworthy hacking news from the industry, we found many more than 10 different classes of real-world examples of things that can take down IoT solutions across the full range of elements from end to end. The device element, as we illustrated, is fertile ground for software bugs, misconfiguration, hardware failures, connectivity inefficient software logic, which we'll talk about a little bit when we get to prevention, and rarely, fortunately, theft or hacking. Radio access networks have local outages, tower-specific coverage and capacity issues, and unannounced configuration changes by regional teams and the MNOs with which IoT devices have difficulty coping with on their own. In the core and cloud, devices gone awry at scale can outrun capacity planning and create outages there too. And in your cloud, misconfiguration or software bugs can create app-level outages, either whole or in part, and they can drive large-scale issues at the device end by providing improper responses as well. Now, we'd like to get your reaction to this list, so it's time for our next poll question. Back to you, Jeremy.
Thanks very much. Stephen, the question that we wanted to put to the audience is this: do these killers of IoT sound familiar? The ones that Stephen's already outlined, is that no, wow, I had no idea all of this can go wrong. Or number 2, I've seen some of these, but I guess there may be new surprises for us ahead. That's pretty fair. Totally, I've seen this all before is answer number 3. Or answer 4, yes, been there, seen that, but you did miss a couple. And if so, if your answer is number 4, please, please share them with us in the chat. So we're getting a strong lead coming through, but quickly, do these killers sound familiar? No, or yes, I've seen some of these, or totally, I've seen all of this before, or there are others, and here I can share them with you. Stephen, what's your thinking on this? There's a really strong preponderance here of I've seen some of these, but there's clearly more to learn.
Well, that actually sort of reconciles with our experience as well, because fortunately, we haven't had any of our customers who've had everything happen to them. It's usually one issue, and in fact, the majority of our customers don't see these things much at all, but things happen, and so again, not much of a surprise that no one's seen them all.
No.
So it looks like we've kind of settled on that. So let's
go back.
Let's proceed on. All right.
Let's go back. Over to you.
Yeah. Let's head on to the perspectives we've gained from having kind of compiled that list. And the other aspect of that that I wanted to highlight before we kind of get into the rest of the story here is that based on our troll through our experience base, which I was talking about a little bit anecdotally there, And so remember those couple hundred ops team escalation reports that I mentioned? That was a long weekend of reading in order to get to a pretty good sense of relative frequency and scale of impact. And those things, have to be considered together across the four essential elements plus transport of the end-to-end, with the device and cloud elements in combination being responsible for the greatest amount of issues and impact. And it's in large part because if you have a large number of devices and a little thing goes wrong, it becomes a big thing just because of the scale. So this finding actually has some fairly significant implications for the tools you need to have at hand when you're addressing our lesson number 2, which, as you'll recall, was prevention and rapid response to issues. We'll start with response, which is usually the most urgent matter. And we'll talk about what we found that is kind of unique about troubleshooting and fixing IoT solutions across the end. There are some unique challenges, and I'd like to illustrate why by starting with an experience that we're all familiar with, which is what we do when our internet stops working, which I hope none of you experience right now so we can finish this. But you know how this works, right? So your internet stops responding. So first you check to make sure your laptop Wi-Fi is connected to your access point. And then you cycle the power on the access point to see if that's gotten wedged for some reason. And then if that's not solving the problem, you power cycle your cable modem or your DSL box, whatever you've got, to make sure it's working from fresh code boot. And when that fails, you call a neighbor who has the same service to see if it's just you or if they're down too, and that may be helpful or not. But if he's still going, then you call your cable company or your telco, and that, as usual, is kind of a big waste of time because the person at the call center can't actually fix anything. They can just tell you, hey, it looks good from our end. So ultimately, in that case, you get reconnected by tethering your laptop to your smartphone's mobile personal hotspot, and you're good to go back to work. In an IoT context, there's something you have to keep in mind that's very, very important to notice about this. We got back online in this story because there's an instance of this incredible thing called the human brain on site, yours, that can apply intelligence, flexibility, and creative problem-solving abilities to the issue, right? IoT is different. There are no brains on site. If a propane tank, for example, is phoning home to report and gets no answer, or an indecipherable answer from the cloud, the tank's logically rigid software will just wait for a configured amount of time and then try again, and again, and again, and again, and again. You get the idea. A programmatic endless loop that is easy to see can cause substantial problems, especially if there are hundreds of thousands of propane tanks with the same issue. The question we want to explore here is, how do we insert some brains back into our IoT network picture? The answer is a thing called the mobile core. Skipping a lot of implementation detail, functionally, the core is involved in everything the network does to support cellular connectivity, controlling who gets on the network, to do what, and how much, at what cost, and build how. Because of its controlling role, the core necessarily provides remote visibility into all device interactions with the RAN and traffic details from the device all the way up to the cloud, which can be essential to rapid troubleshooting at individual device and device pool levels. Further, core visibility into multiple customers' experiences on roaming partners' RANs can help crowdsource information about issues that can be brought to light even before the MNO partners detect them. When our customers experience significant deviations from the norm, they ask us a number of common questions about where the deviations could be coming from, ranging from the geography, the device type, the percent of their devices. Is it an analog radio performance issue versus digital packet logic somewhere along the chain? Which MNOs are involved? What is the network element root cause? What traffic direction was involved? So you can kind of try to find out, where the bad stuff's happening. Cloud endpoint, third-party app involvement, which can happen in the device environment where you've got open networks for other people to use, and so on. Their key concerns are about service recovery, cost containment, and better control moving forward. So the visibility of a purpose-built IoT core, the visibility that a purpose-built IoT core can provide, as we've shown you, sounds like a really good tool to answer these questions and address these concerns, right? But you have to understand there's a wrinkle. There's a significant variation in the extent to which the core information that I've talked about is put to use for IoT connectivity customers, depending on the type of organization providing the service and their principal business objectives. Now, I need to say up front, especially if any of them are listening at the moment, that we have great relationships with and tremendous amount of respect for our mobile network operator partners. So we don't mean this to look or sound like a knock on them, but the reality nonetheless that it's really important for IoT solution providers to understand is that the reality is mobile network operators are primarily focused on and set up to support relatively simple, homogeneous consumer mobile subscriptions in mass quantities. They're really not set up to deal with the complexities of individual custom-built IoT applications. Further, since they've largely outsourced the operations of their networks to third parties, who in turn leave the core software in the hands of large system vendors, there are inherent complications and limitations on MNO's ability to even open a view into a single IoT solution across the network, let alone help when it goes astray. This is particularly true of the cloud and device ends of the solution, which, as we've seen, are at the root of the majority of large-scale issues. Looking at another connectivity provider category, classic MVNOs, it's clear that they are working from a vantage point that is one step even further removed from the action, with only a narrow window into the MNO's networks, and so they're even more hamstrung in practice. The Eris approach, in contrast, is founded on a mobile core and deeply experienced global team. We built both the core and the team exclusively for IoT, with super transparent access for our customers to its information. It'll be helpful to illustrate what this approach can support with a couple of specific examples. You'll recall the customer I mentioned earlier with the 500,000 runaway devices that were causing millions of dollars in overages. Turns out they created the problem themselves with an OTA update to their radio modules that included a bug that caused them to seek information from a third-party site that was non-responsive, and then repeat the attempt over and over and over again, like that bad propane tank I talked about. We found this root cause for them quickly through forensics on their traffic destinations, made possible by our core visibility, and helped them avoid many, literally millions of dollars in overages that would not have been possible without us on the scene. They would have looked for a very long time to figure out that bug, given the obscurity of it. Another long-term customer with nearly 2 million tracking devices in the field is having connectivity performance issues with a new product supported by their direct MNO partner. Companies with millions of devices, tend not to necessarily put all their eggs in one basket. But in this case, the troubleshoot the problem because it was out on the RAN and it was kind of obscure. We identified the issue fairly quickly, looking at tower interaction information, and it was a matter of a receive sensitivity threshold set too low on their module. Not a very difficult problem to solve. You just had to find out that that's what the issue was, given where they were trying to get coverage. Our recommended higher setting fixed the problem, and they were on their way. A third example is an off-grid solar provider in Africa whose devices were having difficulty connecting based on a simple MVNO model of least cost roaming, which I'll explain in another slide in a little bit more detail. But this tied them to inferior and often failing connections. Our coverage optimized MNO roaming approach, which I'll get to, solved the problem. And in addition, we separately along the way found a bunch of their devices with bad antennas. So now they're off and running, and one of our happiest customers in Africa. Now that we've hit the highlights of detection and remediation, just a couple of examples, let's talk about prevention. We'll review here the lessons we've learned in coverage optimization, app design, device configuration, lifecycle management, security, cloud hardening, and a little bit on prediction, which is in kind of the earlier stages of development. Note that a number of these topics are worthy of potentially whole webinars all by themselves. For today, we're just going to hit the highlights with a special focus on the things that are absolutely the most critical to helping address the stuff that goes most horribly wrong, informed by our experience. Our first preventative measure is ensuring optimal coverage. To understand why this is a concern, you first need to know how mobile devices are controlled by default. And again, this is one of those things that our smartphones all do. We have no idea what goes on, underneath the glass screen. But there's a thing called the roaming priority list in your SIM. So with a standard SIM from MNO, that priority list is set up with rules that are configured to favor the MNO's own towers, regardless of whether or not they have the best signal strength in a given situation, because that minimizes the MNO's costs by avoiding charges they would otherwise have to pay to their roaming partners. Makes perfect sense for them to do this. And under most circumstances, consumer smartphone users, they don't pay any attention to this. They just move closer to the window if they need to. But for IoT devices, this is trickier. So with an Era SIM, given the structure that we've set up with our carriers, the structure of our relationship, tower selection can be based instead on maximizing connection quality, which increases the odds that your poor IoT device out there with no one around to help it is going to get better coverage. And that's exactly what was happening with the solar provider in Africa. It's what's happening with our propane tank customer and so forth. It's true even, by the way, in mobile applications where you think this would be kind of less of a big deal. But as any of you who've traveled around the United States much know, it's a big country with a lot of wide open spaces. So what we found through a lot of drive testing is that this preference for the best tower as opposed to the least cost tower will give you up to 20% improvement over any single MNO's network. Our customers in Africa have seen even larger gains because of the sort of dynamic nature of coverage and mobile operators in that region. Next is application design. We've found that with connected vehicle programs in particular, where there's a consumer-facing application involved, it's key to build network awareness into app functionality and into state instrumentation and logging from the app that can help first-line customer support resources identify root causes of problems when people call in. For example, remote vehicle operations like open trunk to receive a package or start engine in order to run the heat or air conditioning to precondition your cabin, as it's called, involve a connection from the driver's smartphone to the cloud and then back to the car. If the phone is connected, but the car isn't, maybe because it's in an underground parking garage, remote operations will fail, generating support calls that cannot be easily resolved when the car re-enters coverage and everything's working normally. To prevent this, it's best to check the car or device's status regularly and address the implications of that in the mobile app. These status check and logging ideas also apply to other devices in the scene like sensors or cameras that can have similar performance issues. As we've noted on the Unpack the Device page, the combination of SIM, radio module, and device behavior is a common cause of issues. Our best practices list here, some of which is admittedly a bit technical, so forgive me for a minute, includes, number one, randomizing the timing of reporting connections across pools of devices. If you have everybody trying to talk at once across your entire network, you can take down towers and potentially your cloud. So randomizing that timing helps distribute the load. Number two, creating RAN connections only when needed and tearing them down when complete avoids dangling and unused resources in the network. Number three, you want to register only for the resource types you need, either circuit or packet switch, but not both if you don't really need both of those, just to limit the amount of costs and complexity that you're imposing on the network, and that'll work well for you. Number four, you want to implement a watchdog timer that at the edge device that launches a secure edge system reboot of the whole thing in case of persistent connectivity failure. This is the equivalent of rebooting your laptop when Windows goes unrecoverably astray. But remember, in this case, we don't have anyone around to reboot it. So that needs to happen automatically in case something goes wrong. And therefore, you can reduce the odds of bricked and lost devices in the field, which are expensive to go get and recover. So number five, you want to make sure you're supporting, I think we advanced the slide one too fast. Here we go. Number five, you want to make sure that you're supporting the roaming list updates for the preference that I talked about and treating them as read-only so you can take advantage of coverage optimized roaming consistently. So now we get to lifecycle management. Now this is one of those subjects that could have its own webinar. But for today, I just want to talk about the most important thing by far, and that is making sure that when you do an over-the-air update to any or all of those several software layers in your connected thing, you have to make sure that those are absolutely flawless, since the downsides of the failed or buggy software update can be huge, as I talked about with our 500,000 devices customer. This may seem like stating the obvious, but experience suggests it's not really that obvious for everyone. So let's be super clear. It's essential to define a small pilot or test subset of your devices where you can prove that it's absolutely flawless without messing up everybody. Number two, make sure it works perfectly end to end, not just at the device, but across the entire chain back to your cloud and across a range of representative conditions out in the real world. After careful evaluation, update the rest of your devices, but not all at once. Do it in batches through controlled, validated stages. On security, fortunately, we haven't seen any malicious attacks succeed in our customer base's IoT solutions over the years. We follow a number of multi-layer security best practices with our customers around the network and their solutions. They're essentially industry convention now, kind of the early days of a lot of hacking in IoT with default passwords and so forth are thankfully behind us. These have kept the devices and their connections pretty well protected. Where we're moving now from a security perspective is kind of the safety of the system overall, and it's about throttling and data caps to prevent what amount to self-denial of service attacks when devices go awry because of configuration issues or software bugs. I'll talk about this a little bit more in the cloud hardening case. And separately, making sure that you're monitoring very closely edge networks like Wi-Fi that are exposed to potentially unsanctioned usage, which can drive up your costs for no good reason. Think of a nurse using a connected healthcare device to surf Netflix on her coffee break, right? We've seen that happen. So hardening cloud operations, the last topic on the kind of the concrete prevention side here, is also worth probably a couple of separate webinars. But today, I just want to hit 3 high points. Number one, when you launch a connected thing with a highly data-driven cloud-based application, you need to realize that you're now in a different class of software business than you may have been in the past, which means you can't stop your app work after you launch it. You have to engage in a continuous cycle that all of the social media operators really understand of performance management, supporting progressively higher scale, greater functionality while maintaining responsiveness and cost control, goals that inherently work at cross purposes. So it's an interesting challenge. There's a lot of lessons learned in the cloud application business about that, but it's just something that it takes a consciousness that that's something that you need to watch and be proactive about. Number two, you need to protect your cloud through throttling, I've already mentioned, throughout the solution, at the load balancer, your API gateway, and internal routers, as well as keeping timeouts in your code on the cloud side in sync with timeouts on your devices, so you don't end up with dangling resources on either side waiting, installed conditions. And number three, you need to instrument everything at individual transaction levels to enable sufficiently granular troubleshooting and test and test and test and test with rigor, with a total perfectionist discipline, especially any configuration changes that could yield outages. And we've seen people take down parts of their solution. A whole connected vehicle solution had like 80% of its functionality gone because of a simple misconfiguration in an infrastructure change on the cloud side. And test at production scale before you implement anything in your live cloud, which often people don't think about fully. So our last topic, issue prediction, is a very brief preview of coming events at Eris. The network management world has been leveraging AI/ML techniques for smart monitoring and adaptive alarming for a few years now. And we've been doing the same thing in monitoring our own network, our own core. So we make sure that, as I mentioned, the variety of things that can happen with our customers isn't outrunning our capacity planning. The data set I'm showing here starts with a month-long sample of that same weekly kind of business pattern from the customer example I showed you earlier. And here, a machine learning algorithm is applied to create a confidence interval around what we should be seeing in the next 24 hours based on the last month worth of activity. What this allows is adaptive alarming on deviations, a number of which are clearly shown here, that's much more effective than conventional fixed thresholds. So it's a tighter window around what should be happening, and that allows you, it's hard to predict the future exactly, but that tighter window gives you the opportunity to catch things when they start going astray. Remember 10:30 in the morning on that bad Tuesday? We caught that fairly fast. It was and that launched the investigation into root cause more rapidly than would have been the case if we actually watched that happen for a couple of days. So we're working now actually to apply these tools in more detail and to make them available for our customers to use themselves. Basically, stay tuned for more news on that front. So to wrap things up, I just wanted to say, as we've seen, IoT solutions can go astray in a wide variety of ways. But if you choose your connectivity provider correctly, hint, hint, you'll have plenty of tools and support at your disposal to help you avoid them and to recover quickly if and when the time comes.
Stephen, you've been very generous with your time and your expertise, and I'm very grateful, and I'm sure our audience is as well. Thank you, everyone who has taken part today. Our aim has been to try and show you, with the expertise of Eris on hand, quickly how you fix the 10 things that could kill your IoT application. I'm afraid that is all we have time for. I do hope you'll bookmark our website at iot-now.com. That's where you'll find the latest news, videos, blogs, events, reviews, interviews, and from tomorrow you can stream this webinar from the site. It just remains for me to say a huge thank you to our speaker, Stephen Glapper from Eris. Thanks, Stephen.
Thanks to you all as well.
It's been great. Most of all, ladies and gentlemen, I want to thank you for joining us right around the world. And at this time, more than ever, please keep safe, and we really appreciate the time you spent with us. From everyone here at IoT Now and Eris, bye for now.